So yeah, I wanted to talk to you today about the role of DevOps in data science, or I would say think about it. And just to give you a bit of context about myself, so I'm Florian Douetteau, which is a hard name to pronounce. It's a very French name, E-A-U at the end, but it's Douetteau. Think of it as an Italian name, Douetto, if you want. And so initially, my background is like kind of technical, meaning like back 10, 15 years ago, my actual passion was about programming languages, functional programming, typing system, compilers, garbage collectors, this kind of stuff. Meaning, to sum it up, I used to be a big nerd. And the thing is, as I kind of moved forward in the world of software and programming and so on, step by step, I discovered that most of the software problems are actually human problems. Like, it's all about making people collaborate, communication, and so on, that actually are important when you want to get things done in software. And so typically, also as I moved forward, I discovered that there was all these people I knew very well, the people which were into coders, but that in order to get things done specifically in the field of data analytics, you also had to make people collaborate with business-focused people, which had a very different way to interact with computers, like with their mouse. And so basically they are clickers. So myself, over the years, I became a clicker, actually. And like today, I think I'm like 85% clicker and 15% coders, which is a step back or a step forward, I don't know yet. And so that's kind of how I actually started to work in the data science field and created this product called Data Science Studio, which is like basically a software for data science platform to help people do things on data. So that's the overall context of this. And so as we work on this, we basically started to work with data teams, data analytics teams, which are pretty sizable. Our largest or smallest customer would have a data analytics team of one. So a team of one is good, meaning you are your own manager. That's pretty great. Our largest customer maybe have like a data analytics of 200 people. And so there are lots of kind of organizational discrepancies in those teams. And so it's very hard to understand how those teams will actually organize over the time, and specifically what's the role of operations inside those teams. But so to start with, let's maybe start with a small history of DevOps revisited. You probably all know this, but basically it's interesting from my perspective. Meaning basically the history of DevOps is the story of a guy, Patrick Dubois, which DevOps as a concept. He created it basically. So the guy initially was a developer, which was also doing ops, meaning also quality insurance. Meaning usually when you do development and operations, you end up doing QA, which is sad, but kind of true. And so he basically started by wanted to do this kind of thing in a more agile way. He started to propose, I think, a talk or a bird of feather at the Agile conference in 2008. Then what happened is that in Twitter, there was this O'Reilly Velocity conference, which I think started in like 8-9 years ago, where at some point people from Flickr were telling the developers and operation people who cooperate there to actually deploy 10 times a day. And he was kind of frustrated and said, well, I should have my own Velocity conference in Belgium, which I completely understand, meaning from my perspective, I wish I had my own Strata or Velocity conference in Paris. I definitely empathize with him. And so that's how he actually created the DevOps Day, which then becomes DevOps. At the beginning, it was just a conference. Oh, okay, interesting story. But so over the year, the concept was like, basically, if I was to sum it up, that, well, ops and dev people should cooperate and speak together, and ops should obviously do development kind of things, if I was to really sum it up. And over the years, well, what it means in practice is that if you were into operation back at the beginning of the cloud, what could have happened to you is that at the beginning, maybe your background was not in software, maybe it was, maybe you had some PHP background, maybe you would learn Python the hard way. You would start with the very first version of Puppets, which was kind of working or not. You would start to do some stuff on Amazon before there was even ELB and EBS. And you were kind of trying to do persistent storage with no persistent storage. So that was kind of the situation you were at. And so lots of people actually learned DevOps this way, the hard way, and moved forward. But what is more interesting is that over the years, so at the beginning, the DevOps is like there was a conflict and frustration between the dev and the ops people. Then you combine the concepts as a catharsis. And there is some culture that is created over the internet, well, basically over Twitter, with people using the concept as a hashtag. And then what is actually interesting is that it ends up with tools being created. And so part of what DevOps is today is actually a tool stack, like Puppet, Logstash, Staff, Chef, and so on. So now let's talk about data analytics. So data analytics, well, it's a big subject, big data, analytics, machine learning, and stuff like that. If we want to kind of talk about it in an oversimplified way, the big trend today is that, well, over the last year, it was all about getting more data to do big data visualization, reporting, and so on, with more and more data to get more insights. And these days, the big trend is to get into more automated decision making, using machine learning to actually make the tiny and cute robot on the right, your right actually, to actually take decision automatically, as opposed to the analyst on the left, which is funny. And the kind of other big trend where we're at is like it's as in data analytics, it's all about combining all different data sources, mobile devices, and so on to create these big global systems of personalized IoT, Internet of Things, machine learning, artificially intelligent devices. That's great. But so again, it's kind of the same thing. There was at the beginning this frustration of people with possibly a math background, science background that wanted to automate things, not so obvious to do in development environment, kind of difference to the way to do business intelligence traditionally. And so they found a way to create a new concept, to create a culture around it, share it online, blog, Twitter, and so on. But it's also today a stack of tools that you actually do to do data science. And so the tools here are pandas, scikit-learn, H2O, R, with all these packages, and so on. And so that's today, the landscape for it is quite complex, meaning from a system, I really wouldn't like to be a system administrator for a big data stack these days, meaning, or an architect. So actually today in data, you've got like 6, 7, 8, I don't see. Yeah, 8 different domains, like visualization, statistics, real-time, storage, SQL, NoSQL, so SQLs for analytics, NoSQL for real-time key value access, and so on. And so for all of these domains, you possibly have 5 or 6 good solutions, meaning free to use or almost free to use, open source, well, maybe free to use or not open source, or open source and free to use, or open source and not free to use. You've got possibly all the combinations. And so just because you've got like 5 or 6 possible solutions and 8 domains, it means that if you need to choose one particular software stack, you do have, well, lots of possible combinations. It's like you don't have like 5 times 8 equals 40 combinations. You have like 5 power 8 or 8 power 5, meaning a few millions combinations, possibly 5 million different architecture combinations, which is a lot. And so from a software administrator, system administrator perspective, you can just imagine that you would have a pre-canned solutions, something pre-installed for each of these possible combinations. And that's, I think, the main challenge for people today in data, which is, well, we got over the last 10 years lots of free good technologies, but they are difficult to connect and so on. So we've got lots of moving parts today. It might be very different in 5 days, in 5 years. In 5 days, it would be pretty much the same. But in 5 years, it will be possibly very different. So the other aspect of it is that today, though in data teams, as I mentioned at the beginning, the organization is changing. Meaning before you had a business intelligence team that was reporting to business sponsor. And these days, you've got usually new analytics teams where you have data engineer, system engineers, or architects, analysts, data scientists that actually need to get those things done. So you got a bunch of new roles that appeared over the last 5 years. So one challenge for these roles, actually, from a management and organization perspective, is that, well, you've got this new role that they were hired for, like data scientists, but their actual role within a company these days is pretty different. Well, it can be pretty different in the case in all situations, but it's pretty common that your data scientists end up doing most data cleansing most of the time, just because that's the way it is. Data is not in a clean shape in its natural way. Your engineers are actually plumbers that try to connect different versions of stuff that break over each possible release of different open source software. And you also have the typical guy, which is a data waiter, which actually launch a job on Hadoop and wait until the end that it actually stops. And so he ends up spending most of his time waiting in front of his laptop that the actual job on his large Hadoop cluster finishes, which is very frustrating. But that's the reality of it. And so a question is, so in this kind of landscape with new roles and frustration, what would be the actual role of the DevOps people? I mean, are they in this table, possibly more than you can eat. Well, you need more memory than you can eat, and more hard drive than you can eat, just because the cost of them is not so high compared to the time you will spend answering those people, I think. And you also have something which is far more controversial, which is the get to the latest package culture. Just because when you're into analytics, and specifically when you want to run Spark, MLlib, Python, R, and so on, you've got lots of new packages kind of every quarter, kind of. Meaning the major technology we use at Douetteau, like Scikit or MLlib or Spark, basically they have new releases every quarter, which is kind of fast. Meaning major release that you really want to use because they have new features that people are aware of and that they want to use, not just updates with bug fixes and so on that you could roll out over 1 year. And so here I think that part of the game of building a data analytics framework is to get, well, obviously in the culture of containers, meaning where you've got containers for different applications possibly, and at least for different stages in your framework, which is not so obvious to do, meaning building containers for Python, R, and so on, as well as deploying stuff on Hadoop, which is another kind of philosophy. It's today complex to mix all those technologies together. The controversial part, I think, of it is that you might just want also to have a developer sandbox, which is a particular container where everything can happen, but which is still managed by you, meaning with lots of CPU, lots of RAM, and server you actually bought as operation people. Well, just to avoid that everybody ends up using his laptop to do the analytics of the company. So DataOps, if it was to exist, would be a philosophy, but it would also be a job title, which is actually already existing. I mean, people are hiring DataOps engineer. You've got lots of discrepancies between today, behind what people put. There are lots of discrepancy about the word DataOps on job boards, meaning it can mean data engineers, it can mean system administrator for Hadoop, it can mean system administrator for a large warehouse where I've got lots of MySQLs bundled together. So, but definitely there is a need for people in operations specialize on big data stuff. So, well, first, obviously, if it's a job title, one way to look at it is that it's like data scientist. The practical application of having a new job title is to have basically a raise in your salary. Meaning, data scientist, when you took a new job title as data scientist, meaning when you write your curriculum vitae, well, one possible goal you could have as an individual is just to get into a new range of salary. And as an organization, you also open new job titles, new roles as data scientist, as opposed to, I don't know, developer or statistician, just in order to justify that you can pay these people 30% more as opposed to the statistician or the developers that you have. I mean, when you are in a big organization with HR constraints, it's important to have job titles with actual consistent salaries. Okay, so it can be just about money, but I think that what is actually pretty important in a job description is to understand what you want to do and what you don't want to do as a DataOps. So, for instance, as I mentioned, if you're the guy responsible for DataOps, you want to fight the toy platform anti-pattern that I mentioned before, which is you just install a brand new Hadoop cluster and people find it too slow and so on, so they start complaining and so on. So you need to be the guy that makes things work in terms of performance, obviously. What you don't want to do is to be the guy that decides about each and every one of the languages to use or frameworks to use within the platform. Meaning, it could be that you would like to use Python and Postgres just because it's cool, or, I don't know, Python and Spark because it makes sense, but then you've got people doing geo analytics within your company, and they just want to use Postgres and PostGIS, and that's the way it is. And so you don't want to be kind of the dictator that I think as a DataOps say what people should use. There is another thing, which is data politics, meaning the main reason for lots of data analytics projects to fail is actually the fact that data is sometimes not available. Meaning, that's actually the main reason for data projects to fail. You find a sponsor, you've got the team, you know what is the business problem, but then you realize that the feed that you need, the columns that you need, the tag on the website that could be necessary just to analyze this data is not there yet. And so you've got different ways to do data politics within a company. Like you can try to hunt for big problems and say that it's a really, really big problem that data analytics would solve for your company and convince the CEO of the company to open the gates of data for you and give you a budget. You can be a spider and try to create a network of devices or new APIs or containers of data that people of the company would be inclined to use, and this way get more data into the new data analytics team or data lake that you're building. But possibly, I think that at the DataOps, you don't want to get into those things, just because it's data politics. It's not ops. Another thing that could be of interest, on the contrary, is, well, this idea that if you, well, again, if we take a step back and look at who were the winners of the last decade, where it was all about building content, social network, search, and so on. Basically, Facebook, LinkedIn, Twitter, and Google all are in common that they were able to deploy new version of their application, well, of their website in practice, very, very, very fast. Meaning they were really, really great at releasing. Amazing company with a release culture. So similarly, possibly the winners of this decade of building a smart intelligence device with artificial intelligence and IoT in it would be a company that will know how to release predictive models in production. And so as a DataOps, possibly you want to own this, meaning how you will put all this analytics in production. What would be the architecture for it? Even if it's architecture and not strictly speaking operations, you want to define it because it's lots of moving parts. Another subject is about data privacy. And so data privacy is a big subject these days. And again, so when you are in large organization and want to get data and so on, you might have people in operation or database administration that are trying to find or decide or determine what can or cannot be done with data. But actually, it's a pretty subject matter. First, because from a technical perspective, it's very difficult to understand what data privacy is, meaning anonymization is not a solved problem at all. Just to understand if something is anonymized or not is a very, very complex technical problem. And from a legal perspective, it's also, these days, a very complex problem. So you probably don't want to get into this as DataOps. And so if we were to wrap it up and get into this situation I mentioned of this startup company that needed to build lots of predictive models and stuff like that, to build is a smart app about car driving. Well, today, in order to get this kind of application done, you need to mix lots of different technologies. You need to build complex workflows. Well, this kind of application require one year, 2 years, usually, to actually get things done right at scale in order to be delivered. you've got all the solutions possibly in the market today to do so. You can connect robust workflows. You can make it so all the input data you get is checked. You can make it so that all the models and the way you version the predictive models and the analytics you're building is properly done. You can share the information with business sponsor and so on. And so, but the thing is that even if it's doable, I do think that today most of the organization, from a kind of data analytics standpoint, are not mature in terms of operations, I think. And so a question I do have, which is more a question for you and not a question for me, is where do we stand? Meaning, if you're an organization with data, doing data analytics, machine learning production, do you have a strategy for rollback? Do you know what will happen if one of the data source fails? Do you know if a new release of your mobile app is gently managed by the kind of high-level analytics stack you're building, and these kind of questions? And so just because I'm very curious by nature, so we've put together a small survey on the internet, which was about it, with like, I think 10, 15 questions, ranging from, well, can you do rollback? Do you do A/B test? Well, when you have lots of R and Python packages, do you manage all of them consistently? Do you version the predictive models you're building? Do you have 2 environments, 1 for dev, 1 for production, or 3, 4 for different staging purposes and stuff like that? And so we will release the result of this survey so that people can be more aware of what putting data analytics in production actually is today in the state of the art. And that's it.
Yeah, do we have any questions? No? Just a little wiggle? No? Well, I've got a question for you. I mean, do you have someone with the role of DataOps in your own organization?
Yes. Yeah, certainly. We've got actually 2 people with a kind of DataOps mindset within the organization. And yeah, and basically that's people with a software development background that used to work in big data, but with a strong kind of operational mindset. And having a developer mindset and an operational mindset is not the same thing at all. Meaning developers, and I consider myself a developer, kind of, are used to break things. And so you really need to have people with developer skills, but with an operational mindset, and that know enough about big data if you want to run some DataOps, I think.
And did you have to pay them 30% more?
Yeah, but you know, when you are in startup, when you are a startup with data scientists and data ops and developers and stuff like that, you end up paying everybody 30% more, which is okay, because it's very egalitarian at the end.
Cool. Thank you. Any more questions? Great.
Thank you.
Well, thanks
Thanks.
for your time.